Hello everyone, this is GL from GL Tech School. In this video, I'm going to teach you how to build a face detection application in Python. So let's get started. So what we're going to learn in this video, we're going to learn pretty much everything you need to know about face detection and face recognition. First of all, I'm going to explain the difference between face detection and face recognition. After that, I will explain the algorithm behind it. Then I will implement that algorithm using Python programming language. So what is face detection? The task is pretty simple. Face detection is nothing but locating a face in a video frame or image like this. So it is pretty simple. It is what face detection is. So face detection is fall under the category of computer vision. If you don't know what is computer vision is just like human vision. For example, now human has eye. For example, now I'm seeing the laptop in front of me, a microphone in front of me, a mobile in front of me. I'm classifying objects. For example, I can see all objects in the real world and I can categorize them, I can label them because I have the talent, because the brain is capable of doing it. Human brain has that natural talent, okay? But the computer is not like that. Giving that human vision to computer is what computer vision is. For example, if you make a computer, if you build an AI program which detect faces or which detect a certain object such as laptop or mobile phone, that goes under the category of computer vision project. Okay guys, the artificial intelligence, the computer vision is a subset of artificial intelligence. The computer vision falls in the category of artificial intelligence. Artificial intelligence is nothing but giving the human abilities to computers such as speech recognition and voice recognition and object detection and natural language processing and so on and so forth. So here we are learning about face detection. The face detection goes under the category of computer vision. That's it. What is the difference between face detection and face recognition? So here we are going to learn how to make a face detection, not face recognition. Face recognition is identifying whose that face is that. For example, it is Jessica, it is Kate, this is Nicole. So this is face recognition is nothing but identifying the face, whose face is that, okay? But face detection is nothing but locating the face region in a video or image like this. So we're going to learn how to detect face in this video, not recognize face. The algorithm, we're going to use the Wolver-James algorithm, which is a famous algorithm for object detection. It was released in 2001, and the basic idea is, you can see there are some pieces like this, eyes and nose and mouth. Each piece is responsible for each face features. For example, this piece is responsible for eyes, and this piece is responsible for nose, this piece is responsible for mouth. If it is all combined, the face is formed. And you can see this algorithm works like this. This algorithm is going to this algorithm is going to search through the image for similar patterns. If the patterns is found, if this pattern, so you can see just like a face, this is an eyes, this is nose and mouth. If this pattern found, that means the face is found. And if you convert that image into grayscale, and you can see the eye area is just like darker. So the algorithm is trying to detect a face based on some face features like eye and mouth position and so on and so forth. This is how this algorithm works. If you want to learn how this algorithm works in an effective ways, I have linked the research paper which was released in 2001 by Wolver-James, and you can read that research paper. And I also linked some explanation videos about face detection, Karl Cascade face detection in the description. You can learn about this algorithm in an effective ways. The Karl Cascade XML. So this is the model we're going to use. So this is an XML file. This XML file, the facial features such as eye, mouth and so on and so forth, we're going to use this model to predict a face in a video frame or image and so on and so forth. You can think this is as an artificial brain, and you can see this model is capable of detecting faces. For example, our brain is capable of detecting all kinds of objects because we have been trained of years of time. I can detect I can see and categorize objects easily. I can see faces, I can see human bodies, I can see laptops, mobile phones, I can see table fans and so on and so forth, because I was trained on naturally, because that is the natural task of human. But computers is not like that. We need to train the computers. So this XML file is only capable of detecting human faces, since it was trained on many images of human faces. So we're going to use this call cascade. So like I said before, these features has been inside this call cascade file. We're going to use this call cascade file to detect human faces in real images and videos. If you open that file, you will end up with like some numbers, and you don't need to worry about that. So we will implement it in Python. So the implementation is, we're going to use a library called OpenCV, which let us implement this problem in a simple way. So OpenCV stand for Open Computer Vision. So we use this OpenCV to develop computer vision applications such as object detection, or elephant detection, or human detection, or face detection, and so on and so forth. So we're going to develop 3 files. The first file is going to detect face in images, then we detect image in video, then after that we will detect live face detection throughout the webcam. Okay guys, I will see you in the implementation part. Hello guys, welcome back. This is GL. We're going to do the implementation part here. We're going to create a simple Python script. That script is going to detect faces in images. So we're going to create our image detection. So for example, we're going to create a simple Python script. That Python script will detect faces in images. So let's get started. So first of all, you need to install Python on your computer. If you don't have Python on your computer, you need to install it. I hope you have successfully installed that. If you don't know how to program, or if you don't know how to install Python, I have a complete videos series which contains 60 videos about Python programming from 0 to 100%. If you want to watch that, I have linked that video in the description of this video. I also linked that installation part in this description of this video. If you don't know how to install Python, you just follow that video and install it. After installing Python on your computer, you can go ahead and type call cascade frontal face classifier and click this link, GitHub link. After that, this is the model we're going to use, and this is the artificial brain. In order to explain in a simpler manner, this contains all of the structure of the faces I already talked about in the introduction part. So what you need to do, you just need to click the raw and then save it as, okay, and you can save it on your desktop. It's a simple tiny file. It does not cost a lot of MB or a lot of memory on your disk. After the installation, after the download, you can see here is the file. Okay, after you install successfully Python, you just need to, you can write this code. Okay, after you download it, just create a folder called face detection. Okay, I'm going to copy and put this model inside this folder, because here we're going to work. I'm going to open up my favorite text editor. I use Sublime Text. I'm going to save a file inside that folder. Some weird things pop up, and where's the folder? Okay, face detection, detect, okay, something, detect in images, okay, .py. So now first of all, I need to import CV2. Okay, here's another important thing. You need to install a dependency called OpenCV. Like I said before, OpenCV is a computer vision application. We use this to develop computer vision application. For example, you need to install it. If you don't have OpenCV on your Python or in your environment, it is difficult to develop computer vision application. So I'm activating my environment. You don't need to do that, but I'm using Conda, so I need to activate my environment. So my environment is tech okay. You don't need to do this. If you install Python while using Conda environment, you should do it. Or if you install Python while manually, you don't need to do this. You don't need to activate it. Then you have to install pip install OpenCV Python. it will automatically install OpenCV Python on your computer. I have already installed it, so it alerts me that it has been installed already. So we'll see that. It says the requirement has been already certified, but in your computer it will take some time to install that dependencies. Then after that, after the installation complete, import or CV2, then type import numpy as mp. Okay, numpy as mp. Then you need to type face detect, okay, face model or something like that. You need to say cv2 dot cascade classifier, and you need to reference the classifier. Here's the classifier. You have to put the name of the classifier inside this parentheses. Make sure to put XML. Okay, make sure to put .xml after the name of the classifier. So we have load the model in this variable. Basically what we have done, we have import the OpenCV and NumPy, then we have load the model in this variable. Next step is to read the image. The process is pretty simple. So cv2 imread is a function to read image. So I need to put some images here. I have already have some images on desktop. I have already collected these images. I'm going to copy and put in the folder. Okay, I have put all images in the folder. Now what I want to do, I just need to take one image. So I'm going to read the image 1.jpg. okay, I hope it is a jpg format. Okay, then I read the image. So if I want to show the image, I just type cv2.imshow, the window name display or something, then what I want to show, right? And cv2.wait key. So you can ask me, what is wait key? Wait key is to hold the window. For example, if you don't write this line of code, if I run the script, and you can see that. Okay, run the script and detect image. First of all, I need to open my path. The path name is face detection Python and detect face images, and you can see it opened the image. If you don't use the wait key over here, it will pop up and it will go suddenly. For example, you can see that it shows it and it goes. So in order to stack that image, you have to use wait key 0 and it will stack the image. So the next step is we have successfully read the image using some programming. Now we have to detect faces in this image. It is pretty simple because we have already loaded the model. Our model is over here. Okay, our model is over here. Next, what we need to do, it is the artificial brain, which contains some identification methods, identification talent. Okay, now what I'm going to do, I'm going to convert the image into grayscale. So why do I converting the image into grayscale? Because it is very important. If you don't convert into grayscale, it won't work. So you should do it. cv2.color. I will explain why we convert into grayscale. Okay, then BGR to gray. Okay, we are converting to gray. For example, the color image has 3 channels: green, red and green. Okay, RGB, red and green. Okay, but the grayscale has only 1 channel. That is easy to work with, and OpenCV, this model also needs grayscale image. That is the reason we are converting the color image to grayscale. Now you can see if I display the grayscale image, and you can see on the screen it is gray. Okay, make sure to convert your image into grayscale, otherwise it will find some difficulties of targeting images. So the another example is, if you convert the image, you can see the eye is very darker, and you can see the eye is very darker, so the classifier is able to easily predict. Another reason is if you give the 3-channel red and green, so red and green RGB, okay, that's going to be very hard. Okay, the red and green and blue. Okay, and here what we're going to do is, next step is to type 4. We need to find faces, so I'm going to say faces. So one particular image may have multiple faces, so we need to detect all faces in one variable. So I put the variable name is going to be faces, then I'm going to type the face model and dot detect multi-scale. Okay, I'm going to put that image, okay, and a tweening value. The value I'm going to give is 1.3, then 5. So 1.3. Okay, so what is it? So it is the scaling factor. So earlier in the presentation I have showed you a window is going to scale over the screen. So it is going to scale like this, for example, which is going to scale 0 to bottom. After that it will increase by 5. Then the slider will become big. Then it hits the in. After that the slider will become big, because of the reason, for example, in images the faces may be in many sizes. For example, if the person is near the camera, his face is gonna be big. So in order to detect that face, the slider size has to be big. So we have to choose it like this. For example, it is going to work like this. I think I need some paint. So just saying it is the screen. We have some faces. Okay, we have some bigger faces like that. There are 2 person. One person is sitting near the camera. The another person is far away from the camera. So this is the slider. Okay, the slider is going to start like this, and it is going to slide through the window. After it hits here, it is going to increase 5%, and it is going to do like that, and it is going to increase again, and it is going to slide. After sliding that, and after hitting that, it is going to increase its size. Then it is when it is increased the size, it detect a face. It detect this face, and it is mark them, or it is label them, or something like that, like this. Okay, then it is going to do like this. So whenever it hits it increase by 5. Okay, after the slide come to this size, it can detect this face. So that is the reason we need to put the parameter value, the 1 point. If you adjust, which means if you adjust this, it is the accuracy, basically it is the threshold. Okay, if you adjust these parameters, you will get more face detected. Sometimes you get less face detected. It's everything on this one. So now if you just find faces, okay, faces, and run it, and you can see it returns 1, 2, 3, 4, some list of numbers. So these numbers are representing the position, okay, and position of the face. Okay, now what we need to do, we need to loop through this. In programming, we know what is looping is, because we already familiar with programming. And for and x, y, w, h. So it is the x point, this is the y point. Basically these numbers are coordinates and the height and width. Okay, so I get the coordinates. According to the coordinates, I need to draw the rectangle. So that is the basic idea here. So in faces, then after that I want to say cv2 dot rectangle. So rectangle is the function we need to draw rectangle. Then I should give the image and x and y. Then after that I should put like x coordinates plus height and y coordinates plus height. Okay, x coordinates plus width, x coordinates plus height, and then I should give a color. Okay, it is going to be VGL. So it is some kind of confusion. For example, in real world we see colors like RGB, red, green, blue. But in OpenCV, specifically to this module, this means the OpenCV computer vision module, it is reversed like VGL, okay, VGL, which means blue, green and red. So we have to give some values over here. I'm gonna give 0 and 25 and 25, okay, 0. So this means it is a green color, okay. I disable other colors. So if I give these colors, by mixing 3 colors I can produce other different kinds of colors, but I want to have one fixed color, that's why I did it. Then I should have the thickness of the rectangle. So basically we give the image, we want to draw to this image, then where's the position x1, x and y coordinates over here. We already see when I print this face we will get some coordinates on height and width. So according to that we are going to draw this rectangle. So the next one is, now I'm going to print this one. You can see the face is detected successfully, and it successfully detected many faces. So next I'm going to try with another image, the image 2. The image 2 is going to, you can see that it is going to detect this image 2, and you can see it's detecting my face. So it works perfectly, the classifiers work perfectly. And I'm gonna try with image 3, okay, image 3. So I execute it. It works perfectly, and you can see it detected many faces, because since this photo has a lot of faces, it detected successfully. So we're going to try with image 4. I think I have image 4 in it, okay, and I'm going to execute it, and it works perfectly. Yeah, it's detecting many faces in images. Okay guys, in the next section I'm going to teach you how to detect faces in videos.